What did we do last? Hey guys, how are you going today? Sorry, just trying to remember what we did last. What did we do last? We did rates of change last time. That was on 26th of September. Okay. Rates of change, was it? Yeah, looks like rates of change. Hi Zoe, welcome. What do we want to work on today, folks? Look, again, we'll do like a couple of excellence questions. If you guys have like any particular year that you have an excellence question that you need help with, give me a yell out. Integrations. Lex, I've actually shared what do you call it? The big document on the community page of YouTube that tells you when the next tutorials are. I will see if I can paste it. Copy. You can check it out here. Here we go. Check that document. That document will tell you when the tutorials are. No probs. How do you get rid of this stupid emoji thing? I'll just pin that message there. If you don't have a choice, or if you don't have an idea, then we could do, did I do a question last time? Yeah, looks like it might have been like 20 something. Oh, we did that last time, Lex. That's why I'm not going to do that again, because we actually did it on rate of change question. We did that on 26th of September. That was the last tutorial I did for differentiation. Can we pick another topic? Otherwise, we can. I'm happy to pull up a couple of excellence questions and give it a go from there. Let's have a look. (2016 2E). All right, let's have a look at 2016 2E. Bear with me because I've got to actually copy the question onto there. Is 2016 2E an optimization question by any chance? Typical? A curve. Oh, yeah. Let's do this one here. All right, let's give me a second. I'm just gonna copy this. We're gonna start off with 2016 question 2E. There we go. That's a nice optimization question, actually. Yeah, it's just coming up. Hold on. There we go. Yeah, definitely optimization question. I think I was actually working with the level 2s for this optimization question right now. Like with optimization question, it's... Should I give you guys some try to attempt this question first? Maybe I should give you guys some time to attempt this question. But before I give you that time to attempt the question, just remember these kind of little tips with optimization. Optimization, what you have to do is you have an equation. So in this case, you're looking for maximize the volume of the cone. But the constraint is that the cone is actually inside a sphere. So when you calculate the volume of the cone, and all you have to do is just differentiate it, put it equal to 0 and solve. But the problem is you will have to get rid of one of the terms. So what I will do is I am going to give you guys, what's the time right now? So the time right now is like 8:09. I will maybe give you guys about 3 to 4 minutes, and then at 8:13 I'll actually go through the answer. But what I will do is at 8:11, should I start? No, let's go 8:13. Give you guys 4 minutes to try and do this. Hey Marco. So volume of a cone, by the way, let me just show you guys where that is in the formula sheet, because that is quite useful to know. I mean, I always forget it. I mean, I don't know, just can't seem to remember it for the life of me. It's not like I need to use it at any given moment, but volume of a cone, there it is. That's 1/3 pi r squared h. That's the volume of the cone that you're going to be using. And then I might just screenshot this and put that in there so that you guys can actually have a look at it. Yeah, so 4 minutes, guys. Have a go at this question, and then what I will do is I'll actually go through this with the answer as well. Yeah, I'm kind of tinkering with this as well, just having a look at what we need to do. H is that, but why is it that s plus r squared? I'm gonna have to go back to my old notes, guys. While you guys do this, I am just gonna go back and have a look at this. What is this, 2016? Well, why did I do that? Ah, idiot. Of course. Of course. All right. Okay. It's a puzzle. It's a lovely little puzzle, but I think we're good to go. All right, guys. I'm going to get started with this. Yep, that's one of the things. All right, let's go through this. Okay, so it's a really kind of good question there, Lex. It's like, you know, you kind of, and same with your typical, you're like, I don't know where to start from. The kind of trick to this is, you know, the first thing that we know is that I've given you guys the volume equation. We need to actually differentiate, find the value of S. So what we're going to do is, and I think the clue is actually given to you guys with the base of the cone is S below the x-axis. Now, not that. I'm actually talking about this. The clue is actually given here. Find the values of S, which maximizes the volume of the cone. All right. Now, if you look at the cone's equation, we actually have r squared and we've got h in there. We've actually got two different letters, and what we need to have in there is we need to replace it with s. Because if you look at the question actually says find the value of s. So, you know, and other times we actually write this with volume of 1/3 pi r squared, but then h, we write it in terms of r, the height in terms of r. Well, that's when we differentiate it, we're actually going to get dv dr, and if you put that equal to 0, that's going to give us with r, and we don't really want that. We want it with s. So what we have to do is we have to get rid of the r squared, and we also have to get rid of the h in terms of s. So the first thing I'm going to do is, I think I saw someone actually write this. Mahir, you actually put down h is equal to 6 plus s. You're on the right track, because if you look at the height, this height of this cone is actually from here to here. All right, that's the height of the cone. Now, I know right now it looks three-dimensional, but if you think about it, if the tip is there from there to here is 6, and then the s, as you can see in the diagram, it's from here to here. So our first thing that we can say is that the height is equal to 6 plus s. Now, let me know if you guys are good with that, because that's the first step we need to do. We're going to get rid of h, and we're going to leave it with 6 plus s. All right, and this is what you need to do with optimization questions. You always have to get rid of one of the letters, right? Now, if I go back into volume, and I put down 1/3 pi r squared, 6 plus s. Now, I've managed to get rid of the h, but the problem is I've bought an s. So I need to figure out a link between r and s. So I need to figure out a link between r and s. Now, one thing that will help you guys is like this, and I think it took me a couple of seconds to look at it again to realize what was happening. So I did the lazy thing. I didn't actually draw a diagram, which I should have. Normally I would have done a diagram like this. That's a terrible, terrible looking sphere, but you get the idea. And we have a cone that looks something like this. All right, so if that's the case, the only kind of information that we have at the moment is the s here, which is from here to here. So this is what the s is. From there to there is s. Now, the other thing that we also have is the radius of the cone. This is the radius of the cone. And we are trying to make a link between r and s. Now, when you look at those green line and pink line, you're like, what do I do with it? All right, I can't really do anything with it. That's my first thinking. But one of the things that I've learned to pick up is that, especially with differentiation, there's a lot of times when the right angle triangle comes back to play. So what I'm going to do here is I am going to actually put a little right angle triangle, because I know that the red line is actually equal to 6, because that's from the center to the edge of the sphere. Let me know if you guys are happy with that, what I've done there so far. While I'm waiting for that, Emery, I think engineering, you've got a month. Just start going through my old, I think I did my old tutorials, which kind of goes through most common questions that come in an exam. They all tend to be merit or achieved. You can easily pick through that, man. Just watch through that, you'll be fine. Now, I don't think you needed to use sign there, Martin. Okay, Crozer, it makes sense for you. Okay, so with that in mind, what we actually have is we've actually written an equation for r squared, because we know when we look at that right angle triangle, we can actually say r squared plus s squared is equal to 6 squared. I think if you're using sine, you might complicate it a little bit, but I don't think you need to, is what I'm trying to say. So when that's done, I could actually write down r squared is equal to 6 squared minus s squared. So r squared is equal to 36 minus s squared. So if you look at this, what I've done now is I've actually got r in terms of s. So my volume equation will now equal to, volume is equal to 1/3 pi 36 minus s squared multiplied by 6 plus s. I'm going to leave this here for you guys because I think from here you should be able to differentiate and figure out what s is. I'll give you guys a couple of minutes to do this, all right? So have a go. EP, I'm not sure. I don't think I can answer that question. I think every university has like a different requirement. So sorry, it's definitely out of my domain of what I know. Typical yellow, it's a really good question. Now, if you think about it, this is a sphere. This is a sphere with a radius of 6 centimeters. That means from the center to any point on the outside of the circle or the sphere, it's going to be 6. So that's how I know that that distance is always going to be 6. So when I'm looking at it in two-dimensional way, from the center to the edge, regardless of where that cone goes, it will always be 6. Zoe, where did you get the R from? R is just the radius of the cone. So that's why I've only got one side of the cone colored in pink. Well, yeah, Lex, you probably should be doing that. Otherwise, you can use product rule, but I would say expand the brackets. It'll be much more easier. All right, I'm going to give you guys another minute and then I'll go through the final bit of the answer, all right? So expand it first before differentiating, or you can actually do something like where you do product rule as well. Mm-mm. 25 seconds, guys, and then I'll go through the answer, all right? What does he want? Jari's window is only going to work for... Okay. Get back to that later. All right. So let's actually go through this question here, guys. So what we've got here is volume is equal to 1/3 pi. Expanding the brackets, 36 times 6, is that 216? I'm sure it is, but I don't want to be making a mistake right now. 216 plus 36s minus 6s squared minus s cubed. Then volume is equal to, I feel like I've missed something here. No, that's fine. Volume is equal to 216 divided by 3, which is 72. So 72 pi plus 12s minus 2s squared minus s cubed over 3. Differentiating it, 72 pi is going to disappear, and I've got 12 minus 4s minus 3 s squared over 3, that disappears. So what I've got here is v dash is equal to 12 minus 4s minus s squared. Now, I'm sorry, but I'm not going to be sitting there. Well, actually, no. You kind of put v dash is equal to 0. So I'm going to rearrange it. So I'm going to get s squared plus 4s minus 12 is equal to 0, which means I've got s plus 6, s minus 2 is equal to 0, which means s is equal to negative 6 or positive 2. S actually can't be negative 6, therefore s is equal to 2. So the actual differentiation part, putting it to 0 and solving it is actually really easy. The hardest part is always coming up, I wouldn't call it the hardest part. The challenging part is always the coming up with that initial equation. But and I guess the clues are always given to you guys in the actual question, right? Like in this one, it actually says find the value of s, which means when you differentiate, you're gonna get dv ds, which means in your original volume formula, you shouldn't have any s's at all. That means you need to get rid of r squared and you need to get rid of h. So that's pretty much the idea behind it. Now, this is an excellence question, Crozer. I think I only end up doing excellence questions during level 3 tutorials because it's just covers a lot of things, a lot of skills, and sometimes if you're lucky, you get like a nice excellence question and get pretty good at it. Yes, tech gaming solution. Like I said, like if this was a little bit more complicated, like you could just go into polynomial f2 2, and I might have just done straight away -1, -4, and 12, and I'm going to get +2 and -6. You could distribute the pi to the other. Actually, no, you're right. I should have done the pi to the other terms, but I guess because I was a bit lazy. Because if I distribute the pi to the other terms, I would still get pi, and pi, and then pi becomes a common factor, and because that is like pi times that equals to 0, 0 divided by pi is 0, so it kind of just gets ignored. So that's a very good question there, Lex. I think that was just me being careless and getting lucky with this question. Tech Gaming Smart, you will not be marked down for using graphics calculator to solve a quadratic because you are expected to know that at level 1, and so you're not going to be you don't actually get marked down for it. So cool. Any questions with this? I'll actually put some line numbers. We've got 1 2 3 4 5 6 7 8 9 10 11 12 13. Is that an optimization question, Aramundi? Alpha Phoenix? I don't know, man. I don't have answers to all the questions. Jeez. This is a maths tutorial. This is not like a life coach or any of those things. All right, I'll have a look at it. Aramundi, is it? What is it? Erimund F. Erimund F. Okay, so what was it? 2021. Typical, yeah, we can. If you can find an optimization question from the paper. I'm looking at 2021 paper. What did she say? What question was it? I missed it. 2021 3E. Was 3E a rate of change? I feel like it was rate of change from... Oh, no, this is... Yeah, 1E is definitely optimization. I think 3E is just a bit of substitution. Let's try 1E because that question there is quite common. The question 1E, especially using similar triangles. Yeah, let's do this one, and then after that we can, if we have time, we can try that 3E. Just because we're kind of keeping the theme going here with optimization. Hope that's all right, Erimund. Alpha Phoenix, I think if you were in my actual class, my advice would be so much different compared to online where everything gets recorded. But be nice to the kids, Subhash. Be nice to the kids. Tech Gaming Smart, yep. I know a couple of guys that did that. But the thing is, they were also smart enough to know that if they botch it, they covered themselves by doing the merit and achieved questions. So guys, this one here, I'm gonna give you guys about, what's the time right now? We got 8:31. I will go through the answer at 8:34. 8:34 is the answer. Now I will tell you guys this right now, just if you are stuck, I can look at this question straight away and I can tell you that we're dealing with similar triangles, all right? Similar triangles is what we're dealing with. Jojo, there is a message that's actually pinned on the chat. If you have a look at it, that is my link to all the tutorials that are upcoming for the next month. You can find out when integration is there on it. Biggest concern is that I'm talking too much in the day and I'm gonna lose my voice soon, and that's not a good thing if you want to do live streaming. I do, Marco. Not many. I mean, I've got Overcooked and is Stumble Guys on Steam? Yeah, Stumble Guys. We usually do like a Stumble Guys here around every now and then. That's... Wait, but I thought you were making one in Roblox, inside Roblox. Or are you actually doing separate one just for Steam? Zoe, like I love playing what do you call it, like 2v2. It's so much fun, but I haven't actually tried it on Steam. I mean, I played on PlayStation and I really enjoyed that. It's like me and my son play, and me and my wife played that, and tell you what, that's a true test of marriage. Yes, playing Overcooked. All right, guys, it's 8:34. Do we need a bit more time to do this, or do you want me to kind of just guide you with the start? Let me know on the chat. Yep, you're right. Gaming smart. Martin, I see you 1 minute and then my mod puts you down on a timeout. What's happening here, Martin? What is happening here? No, no. I don't play Roblox, Anonymous. I enjoy Minecraft recently. I'm actually gonna surprise my kid tomorrow by getting him Minecraft on his on our iPad. So if you're stuck, here is a hint for you. Always look at three-dimensional shape as two dimensions, and things will start to make sense. So here is the cone, and then we've got a cylinder here. All right, this is the cylinder. Now the key point is that, you know, with this cone there is a middle line like this. Now if you draw this diagram like this, I'm looking at you, Tech Gaming. If you draw a diagram like this, straight away you can kind of see similar triangles. Now if you haven't done similar triangles, it can get kind of like tricky, but like what I mean by similar triangles is this. See how you got this yellow triangle here? This yellow triangle is the same as that. It's a similar triangle to that green one. All right, so if I was to color this green, I'm not going to get a different color. Well, that just boo. I hope that kind of makes sense. It's like, so that green triangle and the yellow triangle are similar triangles. Now if you look at the green triangle's height, the green triangle's height is 3 meters, and if you look at the base of the green triangle, this is 1.5 meters. That means if you look at the yellow triangle, the yellow triangle's no, wait, we want to take the cylinder, right? We want to actually get the cylinder first. If we're going to get the cylinder first, I'm going to go h minus 3 minus 2r. No, 3 minus 2r. Why would I do that? Oh, I see what they've done. Okay. So how do I do this? No, I don't want to do 3 minus 1. That'll just complicate things. I'm gonna break this a bit further down. Give me 1 second. Let me do one more thing here. So if this is the radius from here to here, then the distance for the triangle, the height is going to be 2 times radius. I want to do it in a way you guys can see it. Because it's similar triangles, right? This right here is radius. From here to here, I can write it as r, because that's going to be the radius of the cylinder. If that's r, this is actually going to be 2r. I'm going to pause there because I just want to check that you guys understand what I've done there. Because of the 1.5 and 3, I'm actually saying if the base of that cone is r, then the height of the cone will become 2r because of the similar triangles. Let me know if you guys are okay with that concept first. that's pretty much what similar triangle is, right? Because if I make this anything bigger, it's always going to be half of the height. So the radius is going to be half of the height of the cone. Cool. So you guys are good with that. Perfect. Perfect. Now let's look at the cylinder now. So if I was to look at the cylinder, notice the cylinder's height is actually only from this part to this part. All right, that's the height of the cylinder. Now, if the entire length is 3, and let's say if this is going to be then R, I'm going to put R here now, from here to here. If this happens to be R, then this distance here is going to be 2R. Let me know if you guys are okay with that concept, because I'm looking at that yellow triangle. That yellow triangle, if for the yellow triangle, if the base is R, then the height is going to be 2R, because they're similar triangles. So this is the green triangle, and then for the yellow one inside, it's going to have like that same properties. Let me know if you guys are okay with that. Yes, I'm listening. Would that be h minus 3? No. It won't be h minus 3. Because we're trying to figure out what the height is for the cylinder. So in other words, I'm hoping you guys can see that h plus 2r is equal to 3. Because height of the cylinder plus 2r, which is that little space of that yellow triangle, is equal to 3 meters. So if that's the case, then we can actually say that h is equal to 3 minus 2r. And I think, sorry Judy, I think I can't see the comments, because let me show you what I'm dealing with. I don't know how to get rid of this stupid symbol here that just keeps popping up, and I can't read you guys' comments properly. So somebody type something so that comment goes up. I'll actually type it. Okay, so similar triangle happens when they share the same point and now in proportion. Yeah, pretty much. So it's exactly the same kind of, it's kind of like, you know, when you have like a little triangle like this, and then similar triangle is basically another triangle that's created with that same angle. So basically the green angle here and the blue angle are going to be the same. No, my goodness, this is mind-blowing. After 6 years of streaming, I just figured out that I can pop out the chat. Aramand, you're a legend. Thank you so much. This is cool. Oh my god, I can move it here now. Incredible. But that heart sign is still there. Why do I get rid of the heart sign? Sorry, Arena. Is it possible to use the straight line for h is equal to 3 minus 2r? I'm not understanding what you mean by straight line. Which straight line are you talking about? Oh, 3 minus 2r. Like a equation of a straight line. Yes, Anonymous, yes, you could do that. That actually makes sense to do that. Yep. I see what you're trying to do, because it has a -2 gradient and an intercept at 3. Yeah, that would actually work. If you were to put that 0, 0 there. Yep. Hands down. By the way, what Anonymous Rex is saying is actually doing a straight line equation, which definitely works. Oh, is that what I did in the 2021 video? Oh, okay, well, there you go. That's one way of doing it. This is another way of doing it. That's what I like about Calculus Max. There's multiple ways of doing this. By the way, guys, look, we've just done the hardest part of this question, because the hardest part of this question is actually coming up with the equation. Because if we look at it, now we can put the volume of the cylinder, which is pi r squared h. And that's pretty much it there, because all you have to do is just now replace h with 3 minus 2r, put it equal to 0, find out what the radius is, and then prove that volume is equal to pi. So let me give you guys a couple of minutes to do this, but we've just done the hardest part of this question. I would actually put it to dvdr, Mahir, because we are actually getting rid of the h. Lex, what we did there was, just to kind of give you an idea. So remember, we had a triangle that looks like this, right? With the cylinder that's there. Now what I guess I did before was I actually put an x and y axis there. That's going to be 0. That's going to be 3. That's going to be 1.5. So here, if you look at it, this point here is 1.50, and this point here is 0.3. So when you have those 2 points, your y-intercept, you got y equals mx plus c. So y in this case is actually height, x in this case is radius, c is 3, and then if you look at the gradient of this line, it is rise over run, right? So rise is -3, run is 1.5, this is -2. So we're going to get -2r plus 3, which is what we got here as well. I don't see why not. Why shouldn't it work? I think it will work. But I think it depends on the context of the question, right? Like, so I don't look. Ultimately, guys, look, you guys got 2 methods that you can potentially use, right? So, and you got to pick the one that you feel comfortable in. I always say this, like, and I think I didn't even realize this, right? Like when I was doing this, I used similar triangles to work this out, that the radius and 2r, and that's what I was thinking. But like, I forgot that when I did 2021, when I did it in 2022 last year, I used the straight line equation. Lex, does that actually help you with that? I did 2.598. Why is it 2.5981? Why did you go with slant height? That doesn't make sense, because if the height is 3 meters, how can the slant be 2.5981? ADAC, you don't have to. Please don't. Please don't. Please don't. Honestly, don't. Like, just don't worry about it. I'm all good here. Slant height has to be higher than that, Arena. You're getting V equals to 2 pi. Volume is equal to 2 pi, but they're actually saying it's going to be pi. So where's your 2 missing from, Mahir? Let's have a look. All right, let's go through this, folks. So I've got volume is equal to pi r squared times 3 minus 2r. Volume is equal to 3 pi r squared minus 2 pi r cubed. I think we just want to check that we're on the right track. dvdr, or v dash, is going to be 6 pi r minus 6 pi r squared. So we know that the dvdr is equal to 0 for max. So 0 is equal to 6 pi r minus 6 pi r squared. I am going to take 6 pi r as a common factor, which means I'm going to get 1 minus r. And from here, I can say that r is equal to 0 or r is equal to 1. Now, obviously, r is equal to 1. So I'm actually going to put in volume equation, which is pi r squared times 3 minus 2r. Volume is equal to pi times 1 squared, 3 minus 2 times 1. So I am going to end up with just volume is equal to pi times 1 times 1. So volume is equal to pi. not a fan of this pop out thing because it disappeared. How do I pop? Toggle timestamps. Restore chat. Lex, you can't get positive 2 because the gradient is actually sloping down. That means you've done something wrong. Because if it's positive 2, the gradient will be going up. In this case, the gradient, you can see that when I say the gradient, I'm talking about this part here. See, this part is actually going down, so it has to be negative. It can't be positive. No worries, ADAC. No, I don't think so, Rex. I think I think the challenging part is coming up with the question. I think once you come up with the equation, then you'll be all right. Oh, you forgot the 3. No. That 2R is for the cone. Lex, you don't need to worry about the other line. You only need one of them, right? Because if you were to do it the other way, you would actually end up with a different coordinates. You'd actually have negative 1.5. So your height will end up being, what would it be in that case? Negative 1.50. That's a really good question. Hang on, let me just think about this one. What if you use it the other side? Yes, Tech, I'm getting to that. Because I saw the question that you need to prove that it's a maximum. All we've figured out is just the volume is equal to pi. So I guess we've got to differentiate it twice. So this is part of the reason I always get confused with that notation. So 6 pi r minus 6 pi r squared. V double dash is equal to 6 pi minus 12 pi r. And because r is equal to 1, v double dash is equal to 6 pi minus 12 pi times 1. So v double dash is equal to negative 6 pi. And since v double dash is less than 0, therefore v equals to pi is max volume. Right, now I figured out what's happening there, Lex. If you do the other side, Lex, what you have is you're actually working with negative r. So that's just something to keep in mind. So you're like, you would still get positive 2r, but then you'd end up with negative r. And you don't want to be working with negative r. So that's why you only work with the positive side of it and not the other side of it. Because like, you have to remember, radius is positive, right? Which means you don't actually look at the other side of it, because in the other side, I'm talking about this side here, all the radius are actually negative. So we're not actually going to use that side. You have to use the positive side of the radius. Andrew, this is the worst kept secret. But before I go, Irina, I might actually have to come back to this other question, because we only got about 7 minutes left. I don't know if we can crack it in 7. Let me just have a look at the working. Yeah, that's a beast of a question. I think that's going to take more than 7. It's just a very painful differentiation question, eh? That's all it is. It's just a painful question. Like, lots of working on it. Andrew, yes, sorry. To answer your question, Andrew, yes, I am. I am coming there. Guys, look, I'm sorry, but like, I think 8:50, I'm not going to have time to do another one. But I will remember this question, Irina. Jojo, you asked me when the next tutorials are. Our next tutorials are listed on that pinned message on the chat. Hopefully you can see it. Which class are you in, Andrew? Unfortunately, I'm visiting a couple of classes, I think, but I'm going to drop in by the career center and just have a yarn. Yeah, no worries, Rex. Have a good night. Sleep. Oh, Talia, how did I get r equals to 0 and r equals to 1? I just had that quadratic there because I got 6 pi r, and then 6 pi r is like r is going to equal to 0. And then what was the other one? Was it 6? I put my notes away. Hang on. Let me just grab my notes. And then I had 1 minus r, right? So hang on. Let me just see if I can I add this somewhere? She asked me the question. I gotta answer, man. Here we go. So if you look at this, so see how this is 1 minus r? So if it's 1 minus r, that's going to equal to 0. So r is equal to 1. So that's where I get this from. And this one, I'm actually going 6 pi r times this. So in this case, r is just have to be 0 by itself. So that is how I kind of did that. Hopefully that helped you, Talia, if you're still there. Otherwise, I might have missed you there. This is... I've got a whole range of it. Marco, because I love my Star Wars and Marvel and just like my anime stuff. And of course, I'm not gonna lie. You know, you tell me it's like, what is it? My mom bought me this shit, so I was very happy with that. Doesn't mean I know. I mean, I buy my own clothes, but it's just she's obsessed with buying. I'm obsessed with wearing these kind of T-shirts, and obviously we can't actually find it in New Zealand. So mom's like, "Oh, what do you want? What do you want?" And I'm like, "Look, mom, just give me some $5 T-shirts. I'm happy with it." And so every time she goes to Kmart, she'll pick up like, I don't know, 5. She'll send me a message and go, "What about this T-shirt? Would you like this T-shirt?" And I'm like, "Yeah, I like that one. Send it through, mom." Keeps her happy. No worries, Tech Gaming Smart. Take care. I will see you at the next tutorial. That'll be all fine. Mr. U's class. Andrew, I think I'm visiting Mrs. O'Graham and your maths HOD, and I think the other teacher's name is Mrs. I know her first name. I should know her last name. I think it's Mrs. Walls. Claire Walls? Yeah, I'm sure it's Claire Walls. She's gonna kill me if I don't remember her name. My God. I'm just trolling her. Alright, what else? Thank you for tutorial again. No worries, you're welcome. Typical. We'll see you later. Martin, I had no idea what you've been on about. Yes, Mahir, you can send a question for email next time. That's all good. You're welcome, Marco. No worries, Zoe. Okay, Talia's all sorted. Lex, no. I'm not teaching my son any maths. He can learn by himself. Somebody else can do that stuff. Damn, that's pretty cool, man. Full Lego set of Star Destroyer. Irina, no, I've never actually done scholarship calculus because partially I just haven't done it. Just haven't done it, and then I haven't actually marked it, so I don't really know what's happening with it. Oh, is the Center of Excellence the careers place? Is that what it's called? I don't know. Stacy, you made it for the day. Right. Okay, what else we got? Inverse trigonometric for the exam. Does that... I don't think I've ever seen that come. Andrew, I mean, like, with all due respect, Andrew, like, how do we do this, Andrew? How many people are there in Westlake? Is it like Is there like heaps of people or something? Am I not gonna see you there? I thought I'd just come and you just come and pop in and say hi, man. Like, how many kids are in Westlake? I'm there for a while, Andrew, so you pop over and have a chat. Just like boys high school roll. Mickey Mouse ears. So what? Are you kidding me? You guys got 2,375 kids in your school. That is insane. Oh wow, that's a lot of kids. I didn't realize that. I thought it was like, maybe I would come in and say like, I don't know, maybe there was like 1,000 kids or something like that. All right, sure, Andrew. Now, what's the we need to have a code, right? We need to have a code so I know who it is that I'm talking to. What should we have the code as? Code is, what's the code? No, wait. Come on. Think of a code, Andrew. Think of a code. So I know, because it's like sometimes like Andrew is such a common name. That's why we need a code. Oh, actually, Vader. Vader's Darth Vader. Hello, Vader. What's the code should be? No, definitely not that. Yes, love it, Arena. Yes, that's our code. No, we're not using Martin as his code. Martin, I don't know what you're doing. Arena has got a lovely code. Always look at 3D shapes in a 2D context. There we go. That's a beautiful code language right there. Stacy, trig integration and differentiation. I've got some videos on skills. But I don't think we ever kind of did like a workshop on it as such. Tekio, practice. I can't say this enough, Tekio. You just got to practice for the exams. You got about a month left. I would go through, if you're doing calculus, I'd go through at least one paper a night. Just do all the questions you know. The ones you don't know, try and learn like one question a day, and I guarantee it. By the next month, you'll be all good to go. No worries, your average cringe dude. Mahir, have you got the final answer for it? Because just so that we know that we're actually on the right track. Lex, conic sections, I don't know. Like, I mean, apart from them asking a locus, which they used to do before, where they say find the locus, and then you end up with like a ellipse. Apart from that, I can't actually I'm trying to think about it, but I don't. I hardly see it come through. Okay, leave it with me. I kind of will have a look at it. What the hell happened to my... Alright guys, anyway, look, I'm gonna leave you guys with that. Was it Wednesday Westlake? Do I see Westlake before Westlake? This is insane. I didn't realize that there was 2,300 kids. That's a lot. But I do see level 3s. Okay, Andrew, I'm seeing you before Wednesday, which is 17th of October. There's a tutorial. I might actually catch you guys then. Jojo, my biggest advice for the managing time is this: like you like it's so easy to kind of lose track of time with exams. So I mean, like, I kind of say to folks that you've got to keep an eye on the time. You've got to actually almost write the time at the bottom of each question page, so that you know that you need to be done with that. Like so I guess what I'm trying to say is like there's lots of ways of how to do the papers, right? Like sometimes what you can do is you can actually put a time limit. So when you start like question 1 in complex numbers, you kind of look at the watch and you go, right, it's 9:05 right now, which means by 9:25, 20 minutes each question. That's what you should give yourself. So you almost go and write that time down, 9:25. And then you have to keep checking your watch to go, right, it's like, what's the time? Oh, 9:10. Okay, I'm not up to that. I need to keep moving on with this question. The other thing I'd also recommend doing is read the question from the beginning, right at the start, and kind of make like take like a highlighter or a note and just kind of put like little indications to go, right, I can do this question, I can't do this question. And then the ones that you've kind of said, I can do it, just get them out of the way. Finish them as quickly as possible because you're confident, it's fresh in your mind, and you know how to solve it. And if you ever get stuck in those I can do these kind of questions, you just stop and you go to the next question because you don't want to waste time. Really, really important that it's to manage that time, you kind of have to do the things you know first, and then go and attempt the ones that you kind of semi-know. The ones that you don't know, I would almost like leave it till the last because, you know, it's just it helps you with the brain. Like you have to sometimes slow brain that particular problem. Vader, I'm still at OJC. Yes, 4th year here and still going strong. Lex, use substitution is my favorite, but I think most of the guys that are doing here will probably be doing engineering of some sort if they're sticking around for differentiation. Yeah, I do remember her name. I mean, I do remember the name, but Vader. But I just can't remember, like, whether you're an ex-OSC's person or OJ. Like, I can't remember that part of it. Tech gaming smart, not sure. Depends on, you know, whether you're living in. I'll be honest, tech. If I had that option, and if I'm living out in South Auckland and I have to travel 3 hours every day to get to University of Auckland, I'd rather move to Canterbury and study there and be close to the university. Oh, you are at OSC, okay. Yeah, of course I remember you, Stacey, because it's like, I think I've seen you for the last 2 years at least, I remember. Right, guys, look, I think I'm done today. I need to go get some shut-eye. I've got a big week coming up. Oh, God, I forgot to do the giveaway, which I need to kind of sort out as well. But look, have a good night, and I will see you guys on Tuesday for the next integration tutorial. And till then, take care, guys, and keep getting into the revision mode. If you need like a planner or something, let me know. I'm happy to kind of make one for you guys, just for the just to help you guys with preparing for your exams. Oh, sorry, by the way, before I go, I've got one last question to ask you guys, and I know that I am trying to actually apply for some funding for doing a couple of extra things, and I need some data, so I might actually send a survey to you guys. And yeah, I'll see if I can get some data on like what year level you are and what your identify, like what your ethnicity is and things like that. It kind of helps me with a couple of things, but I'll do that later. All right, but till then, take care, and I will catch you guys later. Planner, yep, I'll try and do something with that. Oh, nah, Arena, it's more about, I just want to get a gauge of what, like where people are using it from, and mainly looking at, like, I'm just kind of looking at a couple of studies, just studying some of my data at the moment, just to see how I can help people a bit more. So that's it. Cool. Sorry, I already said bye. Take care. No, oh my God, she's back with the body pillow. Thank you guys. Catch you later. Bye. Oh, okay. I hear you. I hear you, Arena. Okay, I might actually do that. That's amazing. I will actually put that through as well. Thank you. All right, folks. Take care. See you. Bye.